Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into...
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. It is another Friday evening. And this one is November the 16th, 2018, 9 o'clock in the evening for me here in the eastern portion of North America. Universal time, it would put it Saturday morning, 2 o'clock in the morning, November the 7th, 2018. So you got me live for the next hour. My co-host Nick is unavailable tonight, so it's just me and those of you in the chat room and anybody listening in, of course. And, of course, I always invite everybody to come on into the chat room. Go to our homepage, astronomy.fm, and you'll see down near the bottom where it says chat room. Click on that. Type in a name or not. Just hit log in if you want to. Skip the password part completely. Erase it if there's anything there. And come on in. Be more than happy to answer your questions. If you've got some astronomy questions for me, I'm going to try to keep an eye on the chat room best I can. So more than happy to have anybody coming into our chat room tonight. So let's start out with just the general what's up in the sky with the moon and stuff like that. So last night was first quarter moon, but it was a little later. So technically, it's still pretty much first quarter moon right now. So get some planetary observing in early, give it a little while to set down below the horizon, and then maybe get in a little bit more deep sky observing or faint stuff like that. Technically it was today, but actually it was more like last night that Mars was 1 degree north of the moon. Hope some of you got to see that. I was clouded and snowed out, so I didn't get a chance to see it all, but it would have been a pretty nice one. Mars is still quite visible and still looking pretty red, and those sandstorms are kind of dissipating, so I should be getting some detail on Mars again. I have to crank up the power a little bit because it's getting a little farther and farther away every day and every week and every month. So get the Mars observing in as soon as you can before it'll be in the sky for actually quite a long time, but it just gets smaller and smaller and smaller. It makes it a little bit more difficult to see detail. You have to crank up the power, and then you get sky and air turbulence getting interfering with details, stuff like that. Technically, actually there was an occultation of Mars with our moon. The moon covered Mars yesterday. That was visible mostly from Antarctica, some of it in the daytime, and some of it from the very southern tip of South America. So anybody out there listening in, if you actually saw that, you're from the southern part of South America, come on in the chat room and let me know. It's always fun to know that somebody actually see it. Or maybe there's some pictures out there too. I have to look it up, but I haven't seen anything yet of pictures of the moon going in front of Mars. So that would be about the only place on Earth that was on dry land that would actually be able to see that. Saturday, tomorrow, we got Neptune, 3 degrees north of the moon. Of course, Neptune's pretty faint, but technically, if you want to know where the planet Neptune is, all you have to do is find the moon. It'll actually be in about 4 more hours from right now from this broadcast time, so it's still there. Juno is at opposition, rising as the sun sets, so that asteroid will be visible all night long, and that's kind of a nice one to look at. One of the bigger and brighter asteroids. So there's lots of asteroids out there, thousands of asteroids out there, but a lot of them are really, really faint, obviously. So if you haven't started a list of asteroid hunting, here's one to pick up. Juno. I think Vesta is probably set by now. Well, by now, yes, but even in the early part of the evening as it gets dark, it's right on the edge of setting, so definitely getting too low near the horizon after sunset for Vesta. And Sirius, I think, has been gone for a little while now. Next Tuesday, we'll have Uranus 5 degrees north of the moon, so that would be an easy way of finding that. And next Friday night will be the full moon. Oh, speaking of next week, we have some American holidays coming up next Thursday, so that means our next Space Pirate show and the next. Not too sure about the next Event Horizon. I think they're both going to be repeats next week, if I'm not mistaken. So look for that. Expected because of a couple of American holiday on Thursday. So we'll have repeats for you. Let's see some of the famous news that's going on lately. Well, maybe not the famous stuff. Let's just go with some rocket launches first. Russian Progress 71 supply ship launched to the space station, or launches to the space station. When is that? Today, I think it launched actually for that one. And let's see, I'm going to read it here. Saturday at 12 in the morning, 12:14 a.m. Well, okay, it's going to be mostly tonight for me, a little after midnight when that actually launches. So that looks like that's still to come, if I'm reading this right. Launched at, Saturday the 17th. Yeah, that's what it says. How could it say it already launched at that? I don't know. Oh, well, anyways, a Russian cargo ship going to the space station, and for sure tomorrow, a NASA rocket with cargo is also going to the space station. That's going to be kind of interesting. That's going to happen tomorrow morning, my local time. So from now, it'll happen 9 hours and 18 minutes from now when that's supposed to launch. So you can tune into the NASA website and watch that launch. I think that's kind of interesting. I kind of wonder if how risky is that to have actually two spaceships going to the space station and docking almost at the same time, close enough. That seems like that would be certainly keeping the crew extra busy, having that happen, let alone leaving room for some things that could give them a little extra trouble, and they might need to spend extra time on one, but you got another one coming in right behind it. It could be a little bit tricky. So tune in to websites like heavensabove.com and see if you can actually be able to see those two cargo ships heading for the space station. Might be possible. I think it's I think the Russian one's going to get there on Sunday, and I don't recall when the NASA one is actually going to get there. So maybe that'll be on heavensabove.com, where hopefully you'll be able to see it in your ears. Something I always wanted to see, the Progress capsule going to the space station, or now the Grumman, Northrop Grumman craft heading to the space station too. So it's been a long time since I've been able to see anything like that. We used to see the space shuttle sometimes flying pretty close to the International Space Station, but now it's much smaller rockets, and interesting to find out how visible they actually are. I forgot to mention, say hi to people in our chat room tonight. We've got me, of course. We've got Captain Kremmen, Glenn, and Black Projects in our chat room tonight. And of course, everybody else is welcome to come on in too. All right, let's see. Oh, and Captain Kremmen's posting on the Indian Space Agency's rocket, the GSAT-29 mission that launched. Always glad to hear of successful launches by a multitude of space agencies. All right, let's see. Japanese is on the way. Progress is on the way. Goes up in the morning. Cygnus goes up in the morning. Okay. I think it's from Black Project, some of the launch schedules that are happening. Now it's getting confusing on who's actually launching from where and stuff like that. So check out the NASA website, and if you're I think you're on I think it's a Wallops Island launch, if I'm not mistaken, for the Northrop Grumman one. And East Coasters, well, they would have a chance of seeing it, except for some of those pretty big storms heading that way right now and for the past day or so. So a little bit tough to see stuff through the bad weather that we've had lately. All right, this one's been hitting the news for past day or so. A new meteor crater has been discovered on the Earth. We put that article into our chat room, and these will later get into our Facebook page. You can check them out if you're hearing this program on one of the repeats. You'll be able to look at the articles too. All right. New meteor crater discovered on the Earth. Why didn't we see it before? Because it's covered with ice. Yes, it's on Greenland. Greenland's Hiawatha crater. Well, the ice covering it was a Hiawatha region of Greenland, and there's some probes going all the way back to 2015 that were able to look through the ice, and basically the ice scientists, glacier scientists, were studying it, and they noticed something that looked like a circular object. So they sent a more detailed instrument to fly over it, a radar, ice penetrating radar, to fly over that area and mapped it in much higher detail, and finally confirmed and released the data that yes, there is an impact crater on Greenland. About 19 miles in diameter, or more than 19 miles. It puts it almost 20 miles in diameter, and roughly 1,000 feet deep. Now, if you look at the images that are posted of it, from what I can tell, the altitudes have been highly extended, which is not too unusual for some topographic pictures and stuff like that. To show the detail a little bit better, they might raise the height of nearby mountains or hills like 10 times what they really would be. So it's a much flatter crater than what seems to appear in these pictures, which they don't say that they're actually enhanced that much, but definitely a crater. I think they've collected some ice melt, which they thought would collect some of the dirt and stuff from that crater area, and they measured it, and it is consistent with a meteorite impact. So the Earth has another meteor impact site. I think there's 25 or so major meteorite or meteor impact sites on the Earth. Yeah, the age of this one, a lot of speculation on this one. From as far back as 3 million years ago, and some are saying maybe just 12,000 years ago. I don't know. This is a pretty big thing. It was an iron meteorite about a half a mile wide. And the Earth had a bit of population. I mean, North America had people living on it back 12,000 years ago. So I would think that if it was while they were living here, something that kind of close, might have had issues with the people living here. So I think it's much older than the 12,000 years at the youngest age that was possible. So maybe somewhere a couple million years ago would make a whole lot more sense. So, but I'm sure as they study more of it, and unfortunately, if the ice melts off of it, which is almost a half a mile thick, they'll be able to collect more data on that if they, without drilling, go and pick up some rocks off of it. But hopefully, kind of hope they don't actually have it, melt away to do that study. Generally, better for the Earth and us, but it would make it easier for the scientists to go do research like that. All right. Have anybody actually been to any of the meteor craters that are out there? I think I've only been to one, if I recall. That would be the one in Arizona, the Barringer Meteor Crater. I'm not that far away from an impact site in Sudbury, Canada, but it's still a good 6-hour drive to something like that. So I haven't been up there, but I would like to go up there. It's supposed to be a decent museum and to go visit. just a little ways away. We've got some commenting in our chat rooms, and the Clovis people went extinct around 12,000 years ago. I think there were some recent discoveries of pre-Clovis people here in the southern portion of America. So that would have been, they might have been here earlier than that 12,000 years. Always new discoveries. All right, so that's basically the latest. So it's still covered with ice. And basically, yes, just ground penetrating radars confirmed that impact site in Greenland. Something to go visit sometime. Meteor showers. Don't forget, this weekend is the Leonid meteor shower. Hopefully you've got some clear skies coming up the next couple of days. They should be coming out of the constellation of Leo the Lion, which rises fairly early in the morning before the sun rises. So usually we say, after midnight's the best time. I think several hours after midnight will probably be the best time for observing this meteor shower. In past years, it has been extremely active, associated with a meteor storm, but this year it doesn't look like it's going to be that good. So there should be, one estimate, maybe up to 15 meteors per hour. Just okay, they're kind of bright. These are fast. I think about 120,000 miles an hour or something like that. That's pretty fast. Coming from, let's see, what was the name of that comet? I think that was that Swift-Tuttle? Let's see if it's listed here. I'm on the American Meteor Society webpage. And I had looked it up before, but I can't quite remember which comet it was. But I thought it was Swift-Tuttle. Maybe somebody in our chat room will pop it in there for me and check it. That's one thing about useful. I like having everybody in chat room. Is like if I can't look up some information while I'm talking, then somebody can look it up and pop it into chat room for me. That'd be a great help. Well, hopefully we'll be Now the way a meteor shower like that works is a comet circles around the Earth. Circles around the sun. Let me get that straight. And when it gets close to the sun, it gets heated up. Comets are basically mostly ices, frozen gases, and a little bit of dirt mixed in. So, Temple-Tuttle. Thank you very much. 55P means periodic comet. Temple-Tuttle for the Leonids. Yep. And so the comet goes around the sun, and when it gets close to the sun heats up the gases. They don't melt. Because of the vacuum of space, it goes immediately from a solid to a gas. So basically, it just vaporizes off the surface, sends up a cloud all around the comet. Solar wind pushes those particles off the back of the comet, and those particles remain in orbit. Now, the farther away from the comet is from the sun, the less it outgasses, so it doesn't send particles in orbit around the sun. So only when there is a passage of the comet near the sun that's blowing off particles, that you get a concentrated group of particles orbiting the sun. And when the Earth goes through that concentrated part of particles, that's when we get the best meteor showers. Now, when the Earth goes through that cometary orbit, when there hasn't been any outgassing, that's when we have the least amount of meteors. So we're kind of in between a big cloud of particles. So nothing is really expected to be this year. Maybe a few of them, a few strays that'll be in orbit that we should hit, but nothing really spectacular. The Leonids have had some pretty spectacular meteor showers in times past, but nothing is scheduled as this time, but we're observed this time, but we should be able to see some fairly decent, few, but some fairly decent meteors, and you can trace them down back to the Leonid meteor shower. We're So check it out next couple days, say several hours before sunrise, and hopefully be able to see some. Hopefully you have clear skies. Not everybody's clouded out for almost the entire couple of months like I am. Some areas are. Well, that's just the way it goes there. Oh, let's see where we want to go to. Oh, let me give you the whole rundown, like since we're on the meteor shower section here. I'll just give you the whole rundown right now so you can make a few more plans for what's going to be happening the rest of the month. It's not the only meteor shower. It's probably the best one for the month, but not the only meteor shower. So right around the end of November, peaking at November the 29th, will be the November Orionids meteor shower. And then on November the 26th, we have the Northern Theta Aurigids from the constellation of Auriga. That'll be peaking on the 26th, like I said. On the 22nd of November, the Alpha Monoceratids from the constellation of Monoceros, which is just east of Orion. That meteor shower will be peaking on November 22nd. And then, again, the Leonids. So that's pretty much the wrap-up. So there are a few meteor showers this month. Even at peak time for some of them, you might see one an hour. And you pretty much have a good chance of seeing a random meteor once every hour anyway. So if you watch carefully, trace it back to the to an area that is listed, you're more likely that you've actually seen one of these smaller meteor showers. If you catch a random one, it might actually be part of a shower. For photographing the Leonids, several ways of doing it. One way is, well, a digital camera. Believe me, digital camera nowadays are much easier than using an old film camera. The old film camera days, you had to put your camera on a tripod, point it at a part of the sky, hold the shutter open for, well, depending on your film and sky conditions, between a couple of seconds and a minute, half a minute, something like that of exposure time. Limiting factors are how bright the sky is. If the sky is too bright, general background glow, it'll wash out the exposure. You won't be able to see anything. If it's too short of an exposure, it might not be enough time to actually capture light from the meteor. So you kind of got to get it just right. The more in the dark area you are, the better, because the longer you take a photograph. Now, each of the meteors that fly through the field of view of a camera are very short, split seconds, 1 second at max that'll fly through the field of view. So you have to have fairly sensitive film in order to be able to pick up something that's faint. The brighter the meteor, the easier it is to pick up. And the faster ones are also a little harder because they streak through your field of view. Now, sometimes a meteor won't actually streak through the field of view, and that is kind of a meteor hunter's curse there. You can only point your camera at one part of the sky at a time, depending on the lens you use, not necessarily a real wide field of view. Now, some people say, well, I'm going to just use a super wide field of view lens. Well, the wider the field of view lens you use, the smaller the streak appears in the image. So you got a trade-off of, if you use a narrower field of view lens, that means you're not looking at as much part of the sky. So if you use a wider field of view lens, that means you're looking at more sky, but your meteor image is much smaller. So definitely a lot of trade-offs. And even if it's fairly wide angle lens anyways, you're usually only going to pick up about a quarter of the sky. So that means you've got a 75% chance of not being able to capture the meteor in that field of view. And the usual way is every place you're pointing your camera is the opposite of where the next meteor is going to be. So what can you do? Well, you can basically pick a spot, hopefully you get lucky, point at one part of the sky, take an exposure for as long as possible. If you're in kind of suburban skies, that might be maybe a 5-second exposure, and then the sky glow washes out the stars anyway, so you can't do that. So you might be only able to take a 1 or 2 second exposure. And, well, if you take a 1 or 2 second exposure, the meteor will fly by right in front of your camera. That's always the way too. So you have to keep taking picture after picture after picture. The great thing about digital cameras, they're more sensitive. And if your picture didn't have a meteor streak in it, you can erase it and then use that space for another one. So basically, you can kind of just keep taking pictures until you know where you're pointing your camera, until you actually see a meteor go through that field of view. Then check your camera, check the image, and see if you can actually pick it up in your viewfinder. If you can, then you've actually got it. So it's tricky. Digital cameras make it much easier. Now, if you're in really dark skies, you might be able to hold your shutter open for like 30 seconds. That definitely gives you a much better chance of catching a meteor if you can have your camera open for 30 seconds than just 3 or 4 seconds. Let's see what people are saying in chat here. No show tonight? Yeah, there's a show tonight. Yes, live. That's me, live tonight. All right. Oh, we still got our people. Optronics has joined us in our chat room now from South America. Glad you're here. Optronics, did you get a chance to see Mars near the moon? I think you were just a little bit north of the occultation point, but it would have been pretty nice seeing Mars really close to the moon in South America. And hopefully you got a picture for us to show too. All right. Little meteor showers, craters, rocket launches, nice pictures of Jupiter. Spacecraft Juno had another close approach. This was its 16th close approach to the planet Jupiter, and that occurred on October 29th. Got down as close as about a little bit more than 11,000 miles from the surface of Jupiter. That's pretty close as far as planets distances. So it might seem far from on the Earth here, but to have something 11,000 miles away. But that's about 1/4 or less of the diameter of Jupiter. No, 1/8 the diameter of Jupiter, 11,000 miles. So it actually got pretty close, and they're always great pictures, but no land masses. Everything's always swirly on Jupiter. By the way, those images of Jupiter from the Juno spacecraft are available to the public. You can get basically the raw image and then enhance it any way that you like. So you can change the colors around, you can exaggerate the colors, or you can bring out certain types of details if you want to, all by yourself. Yes, NASA actually encourages that too. So you can pick up the Juno images yourself from NASA and then manipulate them, change them around, enhance them, make them better, do anything you want with those images. That's allowed by NASA. So we've seen some pretty good enhancement of Jupiter's cloud surfaces before by the Juno spacecraft. I can't remember how often it takes to go, and it's a very elongated orbit around Jupiter. Was it like 45 days, something like a month and a half or 3 months orbit before it goes back around and gets close to Jupiter again, something like that. We're going to have to look it up. So we don't get images close up of Jupiter regularly. It's not in a close circular orbit. It's in a very elongated orbit. So it only spends a few days really close to Jupiter and then back way out from it. It's the only way they can get the space probe to get that close to it is if it is in a very elongated orbit and swings out way past Jupiter and then comes in close again. Still more passes coming up, quite a few more passes. So still a great probe giving us really great images of the clouds of Jupiter. Oh, we're at about our halfway point now, so I'll do a little bit of station identification. You're listening to the Event Horizon here on Astronomy.fm radio. It is another Friday evening, and this one is November the 16th, 2018, about 9:30 in the evening for me here in the eastern portion of North America. So Universal Time would make that 2:30 in the morning, November the 17th, Saturday morning, 2018. And I'll be live for the next half hour, so I'm glad you're tuning in, listening. Don't forget, we'll repeat this program. Oh, something just went weird. Well, I clicked something and it had its own sound to it. It's kind of interesting, though. What was I talking about? Oh, we repeat this program every 4 hours with more programming, too. So we have 4-hour blocks. So continuing, if you want to, listen in after this program for the other shows, or tune in for the repeats for the next 24 hours. See what you like out there. We've got some good programs coming up. Oh, let's see. Craters and... I was hesitant to do this, but what the heck. I'm going to show this a sort of a Star Trekian gas cloud. How about that? I'll put it in a chat room here. There we go. It's a cloud of gas in a bunch of galaxy cluster collisions. It's a little deceiving. Now, the blue stuff is gas that's been shot away from the galaxy. One of them, gas clouds looks like the Star Trek Enterprise, and something else. I don't know. Rabbit with a fishtail, however your imagination. Now, the main galaxy we're looking at is a very diffuse pink oval on the right side of the picture. That's the main galaxy, and it's partially colliding with another galaxy nearby, and the gases are being shot out from this gas, from this galaxy collision here. And it's just, it's our imagination. If something looks familiar, we can see it in strange places, like clouds of gas out in space. It looked like a sci-fi story. Oh, let's see. Let's go to some stuff that's actually in the sky. I always like doing these. If you're out when I'm going to be a little bit more northern hemisphere centric on this, because that's where I live. It's just a little bit easier for me. So in the early part of the evening, we've had Saturn, and Saturn's already set. So we've still got Mars out there. Right now, it's in the southwestern portion of the sky from our northern hemisphere observing point. The moon has passed by. It was last night that the moon was actually about a degree or less away from the planet Mars, and it's now traveled several degrees west of the planet Mars, and that's, for me, low in the southwestern portion of the sky in the early part of the evening. Planet Neptune is just north of the moon right now. Yeah, what did I say, about 3 or 4 or 5 degrees north of the moon, something like that. So you kind of use the moon to give you a general idea of about where the planet Neptune is. Neptune being about, what is it, like 9th magnitude, something like that, 8th, 9th magnitude. You do need to know about 8th magnitude. You do need to pretty much know where Neptune is located in the sky. There's a lot of stars that are the same magnitude as Neptune. One clue is that Neptune is much bluer than the stars in the area, but you will need to crank up some magnification to at least a couple hundred power in order to be able to get Neptune to show as an actual disk. The better, if you have a computer-controlled telescope, that'll help you even better. If you're like to jump from star to star to star, you have to have a pretty good star chart. I recommend a pair of binoculars to locate the position of Neptune and then point the telescope at it, increase the magnification so you can see. But it's in the early part of the evening, and fairly easy to get to with any size telescope. It's Neptune near the moon tonight, and Mars out there also. Let's see, we've got some, where was I going to go with this? Mars, and, oh yes, a couple of objects. Well, the main star in that area, the south, in the early part of the evening, is a star called Fomalhaut. Fairly famous star. It's Alpha, well, what constellation is that? I don't remember. Pisces Australis, that's right. Alpha Pisces Australis, Fomalhaut. Fomalhaut was fairly fairly famous a few years ago when it was discovered that it had a band of gas circling around it, which meant most likely planetary formation going on around star Fomalhaut. Fomalhaut's one of the brightest stars from the northern hemisphere, facing towards the south in the early part of the evening. It's a pretty good marker for some other objects. Due west of Fomalhaut, a little bit of an obscure globular cluster called or designated M30. A lot of people don't get to look for this one. They just kind of forget about it. So, being low near the southern horizon, you have to have some buildings out of the way and trees out of the way and stuff like that. And a southern horizon where you're not north of a city, causing quite a bit of sky glow. So, if you got a good, fairly decent low southern horizon from the northern hemisphere, not over a city, M30 will be the globular cluster to try to get to test your optics. I don't have any information on this one, on how far away it is, but I got a couple more to look for. So that one's kind of a nice one to go for. Farther west of M30 and a little bit north is a planetary nebula. This is one that I've always liked. It's designated NGC 7009. With a Caldwell number of C55. This one's called the Saturn Nebula. Through a telescope, it actually looks like the planet Saturn. So not a round planetary nebula, but a round center with extended edges to it. So it gives it a shape that looks like the planet Saturn. Not that dim. It's 8th magnitude, so that's pretty bright, pretty easy to see in most telescopes. The thing with planetary nebulas, even if they're fairly bright, they're usually really small. So you have to crank up the magnitude to really confirm that that's what you're looking at or to pick out the shape. Sometimes it'll look like a fuzzy, greenish spot, barely showing anything. You have to crank up the magnification generally on a planetary nebula to really see what it looks like, depending on what it is and how far away it is. Some of them are pretty easy to see, and some of them are a little bit difficult. All right, we're going to go back to Fomalhaut and then head east of Fomalhaut to 3 different objects. We're going to start out with NGC 288, a globular cluster. Globular cluster is in the constellation of Sculptor. And let's see, we've got some information on this. The magnitude of this one is, what is that magnitude? It's about a little dimmer than 9th magnitude, so not too bad to pick out with a small telescope. It is kind of a spread out globular cluster. It doesn't have a really good concentrated core, so having the stars kind of spread out a little bit bigger, it makes it a little bit more difficult to pick out. So if you crank up some magnification and pick up and have a bigger diameter telescope, it'll be able to show more stars that way, and you'll be able to pick it out. So actually, not too bad of a globular cluster in the early part of the evening right now. Nearby the globular cluster is a planetary nebula called NGC 246. Has a couple of nicknames. One is the Skull Nebula, and back in the late 70s, early 80s, it picked up the name of the Pac-Man Nebula. Nobody really does much Pac-Man anymore, so I think I prefer the Skull Nebula for this one. A planetary nebula. Let's see how far away. Distance is about 1,600 light years away from us. And again, they generally have a kind of a bluish green color to them, which if you use a filter, it actually helps enhance the view by darkening the contrast and just letting the light of the planetary nebula come through, and that helps it helps you see it a little bit better. It does have a star in the middle. It's about almost 12th magnitude, so you definitely need a bigger telescope in order to be able to see that one. And let's go back again to Fomalhaut. So we got globular cluster 288, And we also have a galaxy 253 called the Sculptor Galaxy. Not to be confused with the Sculptor Dwarf Galaxy. This one is the Sculptor Galaxy, a very nicely elliptical galaxy. The brightness is pretty easy to pick it up to. Let's see, what's the apparent magnitude? About 8th magnitude for this one. So again, it's pretty easy to see in almost any size telescope. This one is about 90,000 light years in diameter. I can't remember how far away this galaxy is from us, if I remember. Can't quite remember. Well, anyways, a few objects to look for in the early evening skies. Those are pretty much visible from the northern or hemisphere area to be able to pick them out. So give those two a shot. A lot of stuff happening with galaxy discoveries lately. Let's see. Go with this one. Galaxy collisions. Where is it? I had an article about a galaxy collision that was pretty far back. Let's see if I can get it here. No, it was a galaxy that was combining. Let's see. Sorry. I had this one saved, and it kind of disappeared from my list of things to talk about here. It was a very young galaxy. There we go. Here it is. The most luminous galaxy that's actually eating its neighbors. The galaxy was actually really far away from us. It's about 12.5 billion light years away from us. So that means it was what was doing this activity was quite a long time ago, and it was actually near the beginnings of the universe itself. And that's when a lot of galaxies were colliding and eating other galaxies. Well, it turns out that this galaxy is cannibalizing another galaxy, and that's not too unusual. And what happens when a galaxy cannibalizes another galaxy, a lot of the gas gets drawn into it, sends it down towards the black hole. The black hole makes that gas spin around it, get really hot, emits a tremendous amount of energy, and that's when we call an object, and it becomes very, very bright. We call that object a quasar, quasi-stellar object. It's something that quasars are almost always found really far away, because that's when there was more galaxy collisions. Galaxy collisions in more modern times don't happen as much. They're still out there, but not quite as much, and not as much as way back just after the formation of the Big Bang. So most of the galaxies out there, the bigger galaxies, were actually formed by smaller galaxies. Now this one, not a very big galaxy, and it's not just cannibalizing one galaxy, it's actually eating 3 smaller galaxies. So that means a tremendous amount of stuff is being pulled in from the main galaxy, which is really not very big. Tremendous amount of stuff being pulled in towards that black hole in the middle, and it's lighting it up a lot. In fact, it's, for its size, it's actually like the brightest galaxy back at that era, because of all the stuff that it's actually consuming from the other galaxies. So it's not bright because it's big, it's small, but it's bringing in a lot of fresh stuff in towards the middle black hole that's in that one. They think that the black hole in the middle of this main galaxy is about 4 billion times the mass of the sun itself. So pulling in a lot of stuff. And here's a picture of it actually. There we go. Put it in our chat room here. There you go. Check this one out. This is what a 12 billion year old galaxy looked like when it's got fresh food. All right, get on our chat room here and see if anybody's any question for me. Got a few people putting in some details about some of the stuff we've been talking about. Appreciate that, everybody. Thank you very much. All right, let's see. Meteor showers. Comets. Oh, comets. We've got to talk a little bit about some of the comments that out there. There's a new comment. Let me put in a comment page. I got two main comment pages that I use. One is called Weekly Information About Bright Comets, and the other one is called Chasing Comets. I use both of them as a reference because they have different types of star charts associated with the websites. So on one of them, the star chart is a large area of the sky, and it shows a pretty good sweep of the comet's path through the sky for almost the next year or so. But it doesn't really show detail, so you can't use this chart to pick out exactly where the comet will be. It just gives you the approximate area. And this is on the one, what's the site? The site is called Weekly Information About Bright Comets. The other one is called Comet Chasing. Comet Chasing basically shows the same comets, but the star charts are much more detailed. It'll get you into an area of extreme detail of where the comet will actually be. Let me put one of those charts on here. But it also shows a much smaller part of the sky, and actually can be a little bit more difficult to figure out where the area of the star chart actually is. So let me put this detailed star chart here first into our chat room and take a look at that. There we go. And you can see how much detail it is. It gets stars down to 9th, 10th, 11th magnitude on the chart, but it's a real small part of the sky, so it'll get you really detailed. Now this is good for a one of the smaller comets that are kind of hard to find initially, one that might be hard to find with just a pair of binoculars. You'll need that you actually be able to see it with a telescope, so a detailed star chart is like pretty good for that. The other one from Weekly Information About Bright Comets, let me put that star chart onto our chat room, and you can see how wide angle of the sky it actually is, but it doesn't give you the detail sometimes. Let me put that star chart in there and kind of compare. So I use both of those sites. Sometimes a comet is so easily seen that a wide angle view is good. I mean, if it's between a first and second magnitude star and it's a comet visible in a pair of binoculars, it's pretty easy to scan between two really bright stars that might be 5 or 10 degrees apart, and you'll be able to pick it out. But the comet's pretty faint. You'll have to use the detailed star chart and figure out exactly what day you're observing. Don't forget to compensate for universal time for your area. Usually those charts are labeled in universal time, so you have to compensate for its movement and when you're looking, and you will have a better chance of picking out a faint comet with a more detailed star chart. But I use them both. Let's see. Skyhound and the BAA comet page is also is good, and Sky Live too. Okay, we got some other recommendations. One of those I said was Skyhound. I haven't looked at the British Astronomical Society comet page, and I haven't tried Sky Live in a while too. So several references you can look for finding some of the comets. The two main comets now are the one that's been around for a little while, periodic comet 46P Virtanen. It's actually spelled with a W, Wirtanen. And that one's been kind of a nice comet. It's been around for a little while. It's kind of recently reasonably bright. It's supposed to be more for Southern Hemisphere observers, getting to around 7th magnitude, something like that, maybe just a little bit dimmer. So that one's kind of nice. Let me see if I've got the rough star chart on this one and find out where it's at. Nope, I've got to go to the other page for this one. Oh, sorry. Chasing Comets and this one. All right, so the rough star chart shows this one fairly south right now, Cetus, Fornax, and then it'll be traveling north through Taurus and Riga in the next month or so of December. So that one's been around for a while, and now the newest comet Comet C 2018 V1 MkIII, Fujikawa Iwamoto. Yeah, sorry, my pronunciation's not very good. That's a fairly new comet, mostly recently around. It's in the constellation of Virgo. Virgo has a bright star in it, southern end of the constellation called Spica. Right now, Spica is very close to the planet Venus. This is a very early morning object. Venus, probably want to find Venus early in the morning before the sun rises, as it's just beginning to get a little bit of daylight out there. See if you can find Venus, trace that to Spica, and then head north a few degrees, and then see if you can actually find this comet. Let me put the star chart on here. It doesn't move very quickly, but Virgo doesn't stay in the sky too long either. So kind of a toss-up on how well you're going to be able to see this. So you're going to have to look at it fairly soon. It's just not going to be above the horizon for very long, and that makes it more difficult to actually see. All right, let me put this one in the star chart for that one. So 2 comets to look for, but the one you're going to have to make a serious effort to get up in the morning and find it, though it's actually supposed to be fairly bright too, staying close to the sun. So give that one a shot. All right, in about 9 more minutes or so. Let's see where we want to go with stuff in the sky, or did we go with Barnard Star yet? I don't remember if we went with Barnard Star yet. Anybody remember? Did I talk about Barnard Star? Let's see. Sorry. Yes, problem when I do the show by myself, I kind of lose track of what I was going to say and what I actually talked about earlier. So let's try Barnard Star. Barnard Star, nope. Okay, thank you very much. I did not talk about it earlier. Barnard Star, kind of a famous star in that it moves across the sky with a measurable speed, and that's because of its motion, of the Earth's motion through the sky and the star's motion through the sky, that you can actually measure it after a couple of years, or depending on the detail of your telescope, you can actually measure it moving across the sky. So it makes it fairly one of the closest stars to our solar system. If I'm not mistaken, it's a single star, and it was recently discovered to have a planet around it. Barnard Star is a very red star, so I'm pretty sure it's a red dwarf star. But it's been recently discovered to have a planet orbiting around it, and the planet is thought to be a bit, or quite a bit larger than the Earth, but not like a giant gas planet. So what's called a super Earth planet. The only way to see a super Earth planet is by the planet going in front of a fairly small star. So Barnard Star being a red dwarf star, very red if you look at it through a telescope. A planet that doesn't have to be very big will actually cover a lot more of the sunlight than a really large star will with a small planet. That's why most of the planets discovered first were really large planets close to smaller stars. So it was a lot easier to find the big planets. So the hard part was seeing the little planets. So the best way to see a little planet is when it covers up part of a little star. The light dims a little bit better that way. So Barnard Star has been discovered to have a super Earth around it. I think it's in the Goldilocks zone. That means it's at a distance from the star where it would be possible to have water on it if other conditions were right, the right amount of atmosphere and stuff like that. The only problem with generally red dwarf stars is they tend to flare up a lot, and they'll shoot a lot of UV and stuff like that out into the space environment. And if the planet doesn't have enough, ozone protection, magnetic field, and stuff like that, it could get zapped pretty good. So even though it might have Earth-like conditions, excessive radiation is calculated to basically kind of get rid of any potential of life staying on a planet circling around a red dwarf. So one of the closer stars and one that has a potential Earth-like planet around it. That's been one of the more recently discovered too. All right, so let's see. All right, about 5 more minutes. So let's see where we want to go for this one. Let me check our chat room, see if anybody's got any questions. All right, hope you guys have a good weekend for doing some astronomy. Southern Hemisphere enjoying some warm weather or extremely warm weather from some of the reports I've seen. And the Northern Hemisphere, getting into the cold season. And what was I going to say about that? So everybody's got issues. Oh yeah, we're coming up about a month away or so from the equinox, December equinox. So we'll talk about that as we get closer to that event too. All right, let's see. We're 5 more minutes of talking. I think I've talked before about that interstellar comet thing, Oumuamua. There was kind of a controversial report on it, about it thought to be extremely thin, so thin but spread out that it would actually catch some of the solar wind, and after it went by the sun, and the solar wind would actually be able to blow it and speed up its speed as it goes out into space. Trying to figure out why, but more calculations. Another spacecraft, was it Spitzer, I think, infrared spacecraft, looked at it and was not actually able to see it. So the idea was that if it could not be seen in infrared after so far away from the sun, that it was probably smaller than originally predicted, and colder than originally predicted, which would allow for some outgassing when it went by the sun. So some of the ices turned to gas and gave it a little extra push as it went past the sun, and that would account for its being able to speed up after it went by us. So probably smaller, not as spread out and as thin as the one calculation made. One calculation made that if it was kind of big but really thin, like just a few millimeters thick, that would account for the push from the solar wind. So what would be, especially since they were solar sail experts, what would be a thin, large material that could be pushed by solar particles? And they said, okay, a solar sail. So if it could be a solar sail, then it could be built by an alien culture. That was a stretch, but according to the numbers, it sort of made sense. But the data was pretty rough. The thing came in unseen and was a little ways past its orbit around the sun when it was actually discovered. So we got it basically on the way out. And the longer you waited to look at it, the farther it got, and technically the smaller it got. So nobody was really able to get a good image of it. They were able to see it with regular white light. They could see the white light was basically blinking in a couple of different patterns, almost a random pattern, but a little bit different pattern. So they knew it was tumbling, and they knew it had to be only with a certain size. So some good guesstimates put it at, anywhere from like 200 feet to a half a mile across, like that. So not a really good estimate. So the reflection of the sunlight coming off of it is another way of kind of judging a size. So, but you have to know how much reflective it is. If it's icy, it's going to appear brighter. If it's darker, it's going to appear dimmer. And mixing it with the size and the brightness, kind of a guessing game. So, latest thoughts were, it probably was an icy body, and they just didn't see the outgassing with it, and that would also account, and more likely account for the speed increase as it was traveling out of the solar system. So a little bit more sense there. Let's see. All right, we're almost time to the end of the program here. Let's see, we're having a little technical issues, so I think we're just going to cut this one out real quick here. Thanks everybody for listening in. Appreciate it. Oh, I see what it is. I have to hang up instead of he hangs me up. I appreciate everybody being in our chat room supporting me tonight with this program. And not going to be here for the next two shows. Space Pirates and Event Horizon will be canceled because of our American holidays. So see you after that, everybody. Thanks. Appreciate you all being here. Good night.